everyone. It's great to be here in Boston. Good to see so many of you after hopefully a good night drinking last night. Um, I'm going to start off to what do I do? About a little over a year ago, I left Netflix. I was the chief architect there and basically the cloud architect. I joined a VC firm that's actually based in Boston. So Battery Ventures is a 30-year-old VC firm. It's a good-sized one. We have offices in Israel and in the Bay Area, and I'm based in Menlo Park office, and we have a San Francisco offshoot as well. And this is kind of what I do, all these different things. I want to highlight a few things here, though. I'm doing presentations at conferences. I do a lot of presentations at conferences, and I've been sort of using that as a way to develop ideas. I've actually on the program committee for several conferences, and I've helped out a little bit with this one. I've been tinkering with technologies, and I'll talk a bit about that. If you've been following the Twitter feed, I actually debugged this code this morning and actually uploaded it, and I was pushing stuff to GitHub at about 9 o'clock today. So this is conference-driven development at its best. And I network with interesting people, which is all of you. So I'm happy to, I'll be around through the conference. I want to connect to people. That's my job. Right, is to find these interesting people. If you're going to start a company or you're going to do something interesting, you want to join a startup, that's the kind of thing I'm interested in. And or if you're at a big company or using stuff from, software from startups. So that's what I do. But everyone here, I did a tutorial yesterday afternoon, a workshop, and everyone wanted to hear about microservices. That's basically the summary, so I'm going to talk about microservices. I'm going to start off with my definition of it, and I say this is kind of a useful definition, I think. It's loosely coupled service-oriented architecture with bounded context. And people say, well, SOA was always supposed to be like that. Unfortunately, people ended up building ones that were tightly coupled. So you can tell you're loosely coupled if you can update everything independently, and that's really the goal. And then the bounded context, if you try to figure out how big should your microservices be, go read this 10-year-old book by Eric Evans, and that's the best place, I think, for work out what is a bounded context, figure out how to build something that will fit in James Lewis's head, which is also a bounded context, and that's his definition of microservices. So what do we care about? Well, microservices are there partly so that we can have more speed. And let's look at what's happened over the last few years. We start off with data center snowflakes. You individually hand configure them, you buy them, they sit at the same IP address for the next 3 years. That's pretty typical, right? And then your monitoring system's looking at it. Okay, I know that machine. Maybe its software changes every now and again, but the hardware stays the same. Then we went to virtualized and cloud, where in a few minutes you can stand up a bunch of machines on AWS or another cloud vendor, and you can do that in your data center with VMware or OpenStack or whatever. So and you turn them over every time you go through your agile release cycle of every 2 weeks. You get a new bunch of machines. That's fairly normal. And then we go to containers, where it really takes seconds to deploy a container, a Docker container. And then it takes seconds to test it and seconds to push it to production. Everything's happening in seconds, and it makes sense to create a complete test environment that's going to live for less than a minute, and then tear it down again. Right? And then just to go right to the limit, AWS came out with this thing called Lambda, where they stand up a container to run one event processing step. It's a Node.js event processing pipeline chain. And one thing runs, boom, and then that container goes away again, and they charge you by the 100 milliseconds. So you get the first million requests for free, and then it's 20 cents for the next million or something. So that's interesting, but now you go, well, I'm going to monitor this. Measuring CPU usage once a minute doesn't make any sense at all on the right-hand side. It's like, okay, this thing only existed for 3 seconds. Where did my CPU usage go? Right? Doesn't make sense. So that's a big challenge, coping with this rate of change. Let's look at another challenge, scale. It's not just I've got thousands of machines, and in Netflix's case, about 30,000 machines are being monitored when I left. There's also this hierarchy. There's people typically have machines running in 3 continents. We were talking about Antarctica earlier this morning. Some people probably do have machines running in 5 continents. There's 2 to 4 regions per continent. And then you've got all of the zones in the region. You've got lots of different services in each zone, where a zone is basically a data center. There's lots of versions of each service running at the same time, because you've got the old one, the new one, maybe a bunch of ancient things that something still depends on. And then you've got lots of containers per version, which might take you, might be able to create very quickly. And the total number of instances you're running And this is just one stack. This is kind of the typical way I think about the Netflix on cloud stack. But you could have, a data center, you'd have more layers of the stack underneath. And you're trying to monitor all these things. And there's so many moving parts. So that's a big challenge. The next thing is the flow. How do you get from A to B across this thing? And there's a bunch of tools that try to do this in a small way. Netflix has published some things that will connect together the flow across a few services. The Twitter Zipkin service can do some flow, and App Dynamics can sort of detect what's going on. But they can only really visualize your own bounded context. Who are your clients? Who are your dependencies? That works pretty well. Once you get into what is the big picture for everything, it ends up looking like this. And the problem with how many microservices, that's the graph there shows after about 1 year, Gilt went from a handful to 450 microservices. So this is too difficult. And I'm trying to get people to figure out how to monitor these things a bit better. And then there's failure modes. There's some really interesting failure modes. So if we look at a microservice deployment, this is sort of a Netflix type one. You've got 3 zones. There's an API proxy, some business logic, a data access layer, and a Cassandra cluster. Well, one of the failure modes that we're really, really interested in is a zone failure. And they're called availability zones because the zone's supposed to fail. And that looks like this, right? Now, what's the situation here? What should the monitor show? Is this a major outage? No, this is supposed to still be running. So by design, by design, the message should be, don't touch anything. You're still running, but stop all updates, whatever. Freeze the system. Don't break anything. For the last thing you should do is reboot anything, right? Because it's usually the first thing people do. So there's this challenge. There are several other interesting patterns here which are fairly common, which need to be understood by monitoring tools. Then there's testing. How can you test, if you're building a tool, how can you test it at scale? Well, it just gets expensive really quickly, right? You've got, if you're setting up to 1,000 machines or 10,000 machines on a cloud, that can cost a lot. Even if they're containers, it's going to cost you a lot to run it. So I'm going to talk briefly about simulation and introduce this tool I've written. I told you I was tinkering with things. I've built this thing that can, and this diagram is some D3 JavaScript code, and this is my first ever JavaScript program, and if anyone out there is a JavaScript visualization developer and wants to play with this, I need help. Seriously, I need a lot of help. My JavaScript code skills are really, really not there. But however, I've written this thing in Go in the back end, which I'm actually much more comfortable with, and it generates these interesting architectures. This entire architecture, or much more complex architectures, can be specified in a few lines. I can scale them to roughly 100,000 nodes on my laptop. And I can generate metrics from that using sort of Coda-Hale's metrics library or whatever other library you want to actually stress test systems. I want to basically use this to stress test interesting behaviors and architectures into monitoring tools. So that's what I'm trying to do. I actually did a code. This is conference development. I fixed some bugs this morning, got this thing out. So just to wrap up, this is what the code looks like to create the architecture shown, which is there's at the bottom on the right, there's a 12-node Cassandra cluster. There's a MySQL, the 2 little yellow dots, which are master-slave pair. Then the 3 little blue ones in the middle are a Memcache cluster managed using EVCache, which is a Netflix library. Then those purple things are data access layers that have all that storage stuff hiding behind them. You do REST calls into that from your Node or PHP or whatever microservices, which are the brown and green dots. Then there's a API proxy in front of that, which splits the traffic across them. And then in front of that, the blue dot is a load balancer, an ELB, which splits traffic across the 3 zones. And you can specify that you just do bottom up, and the names have to match. You can have arbitrary list of dependencies on the right, and you just connect up the names, you're done. These few lines of code are buried deep into a large file of random other stuff that you can ignore. But if you want to create your own architecture, it's pretty easy. So this is the challenge. Go figure out what an interesting architecture, build your architecture, stress monitoring tools with it. I'm looking for contributions and help with this. I have an office hours lunch table, 12:15 in Ballroom A. Anyone that's particularly interested, see you there. And I uploaded these slides to SlideShare this morning. So hopefully get a few people to join in and help me. Thanks very much. Cheers.